Coordinate geometry is one of the most important ideas in mathematics. It provides connection between algebra and geometry through graphs of lines and curves. This enables geometric problems to be solved algebraically and provides geometric insights into algebra. In coordinate geometry, points are placed on the coordinate plane. It has two intersecting coordinate axes, the horizontal axis known as the x-axis and the vertical axis known as the y-axis. The point of intersection of these two axes is called the origin. The plane is divided into 4 quadrants. Each point of the plane corresponds to an ordered pair called coordinates. The first number in the ordered pair is the x-coordinate or the abscissa, while the second number is the y-coordinate or the ordinate. The method of describing the location of points in this way was proposed by the French mathematician René Descartes. He proposed further that lines and curves could be described by equations using this technique, thus being the first to link algebra and geometry. In honor of his work, the coordinates of a point are often referred to as its Cartesian coordinates, and the coordinate plane as the Cartesian coordinate plane. In this video, you'll learn the basics of coordinate geometry. Specifically, 1. Determine the distance between any 2 points on the coordinate plane. 2. Determine the coordinates of the midpoint of the line segment joining 2 points. 3. Apply the distance and midpoint formula in solving problems involving some geometric shapes and their properties. Suppose you want to find the distance between any 2 points on the plane. In the graph shown, to find the distance between points 2, 3 and points 2, negative 4, we simply count the units between the 2 points. The distance is 7. Since the points lie on a vertical line, the distance may also be obtained by subtracting the y-coordinates. 3 minus negative 4 is equal to 7. If the points lie on a horizontal line, the distance is obtained by subtracting the x-coordinates of the points. What if the 2 points do not lie along a horizontal or vertical line? The Pythagorean theorem is used to determine the distance between these points. Example: find the distance between the points 4, 2 and 1, negative 2. Solution: plot and label the points in the Cartesian plane and draw a line segment indicating the distance d between the points. Form a right triangle by connecting the points to a third point, 4, negative 2. Calculate the length of the horizontal segment. 4 minus 1 is equal to 3. Calculate the length of the vertical segment. 2 minus negative 2 is equal to 4. Use Pythagorean theorem to calculate the distance d. D squared is equal to 3 squared plus 4 squared equals 25. D is equal to 5. We can obtain a formula to determine the distance between any 2 points, x sub 1, y sub 1, and x sub 2, y sub 2. The distance along the horizontal segment is the difference between the x-coordinates, x sub 2 minus x sub 1, and the distance along the vertical segment is the difference between the y-coordinates, y sub 2 minus y sub 1. Example 1. Find the distance between negative 3, 5 and 2, negative 1. Solution: let x1, y1 be negative 3, 5, and x2, y2 be 2, negative 1. D is equal to the square root of 61. Note that we can interchange the values of x1, y1, and x2, y2 and still obtain the same distance. Pause the video and try solving the distance when these values are interchanged. The midpoint, x sub m, y sub m, of a line segment joining 2 points, x sub 1, y sub 1, and x sub 2, y sub 2 is defined as the point that lies on the segment which has the same distance d from both points. The coordinates of the midpoint are found by averaging the x-coordinates and averaging the y-coordinates. Midpoint formula: x sub m, y sub m. Example 2. Find the midpoint of the line segment joining the points 3, -4, and 5, 8. Solution: let x1, y1 be 3, -4, and x2, y2 be 5, 8. xm, ym is equal to 3 plus 5 over 2, -4 plus 8 over 2, equals 4, 2. You may verify your answer by plotting the given points and the midpoint. Now it's your turn. Pause the video and answer example 3. Example 3. Find the midpoint of the line segment joining the points -1, 2, and 5, -4. Let x1, y1 be -1, 2, and x2, y2 be 5, -4. xm, ym is equal to -1 plus 5 over 2, 2 plus -4 over 2 equals 2, -1. Now, let's try to answer more challenging problems. Example 4. Show that the points -2, 3, 4, -5, and -2, -7 are vertices of an isosceles triangle. Solution: plot the given points on the Cartesian plane. Then connect these points to form a triangle. An isosceles triangle is a triangle with two sides of equal lengths. So to show that the triangle formed by the three given points is isosceles, we have to show that there are two sides of equal lengths. Use the distance formula to determine the length of each side. AC is equal to 3 minus -7 is equal to 10. Since AB is equal to AC, the triangle is an isosceles triangle. If 4, 6, and 0, 2 are points at opposite ends of a diameter, what are the coordinates of the center? Solution: plot the given points on the Cartesian plane and sketch the circle. A diameter is a chord that passes through the center of a circle. Thus, we can use the midpoint formula to obtain the coordinates of the center of the given circle. xm, ym is equal to 4 plus 0 over 2, 6 plus 2 over 2 equals 2, 4. The center of the circle is point 2, 4. Example 6. Show that the points A, 2, 3, B, -3, -2, C, -7, 1, and D, -2, 6 are vertices of a parallelogram. Solution: there are several properties that we could use to show that quadrilateral ABCD is a parallelogram. First, plot the given points on the Cartesian plane. Solution 1. Using the distance formula, we can show that if opposite sides are equal, then the quadrilateral ABCD is a parallelogram. Conclusion: quadrilateral ABCD is a parallelogram. Solution 2. Using the midpoint formula, we can show that if the diagonals bisect each other, then quadrilateral ABCD is a parallelogram. Midpoint of diagonal AC: -7 plus 2 over 2 and 1 plus 3 over 2 is equal to -5 over 2, 2. Midpoint of diagonal BD: -2 minus 3 over 2, 6 minus 2 over 2 is equal to -5 over 2, 2. Conclusion: quadrilateral ABCD is a parallelogram. You may practice what you learned in the exercises found in this module. Happy learning!